Imagine a time, before space, before anything. That was the state of the universe before the Big Bang. Scientists have been trying to understand the origins of the universe for centuries. But it wasn't until the 20th century that they developed the first scientific theories about the Big Bang. The Big Bang theory is the most widely accepted explanation for the origin of the universe. It states that the universe began as a singularity, a point of infinite density and temperature. About 13.8 billion years ago, the singularity expanded rapidly, giving rise to the universe we know today. But what was before the singularity? And how did it come into existence? These are some of the most fundamental questions in physics and cosmology. And while scientists don't have all the answers, they have developed a number of theories about what might have been before the Big Bang. One of the most popular theories is the quantum vacuum fluctuation model. This theory states that the singularity arose from a tiny fluctuation in the quantum vacuum. The quantum vacuum is a sea of energy that is constantly fluctuating, even in empty space. Another theory is the braneworld collision model. This theory states that the singularity arose from a collision between two braneworlds. Braneworlds are hypothetical types of universes that exist within a higher dimensional space. A third theory is the cyclic model. This theory states that the universe has always existed and that it goes through an infinite cycle of expansion and contraction. There are a number of different theories about how the singularity came into existence, depending on which theory about what was before the Big Bang is correct. For example, if the quantum vacuum fluctuation model is correct, then the singularity came into existence from a tiny fluctuation in the quantum vacuum. If the braneworld collision model is correct, then the singularity came into existence from a collision between two braneworlds. And if the cyclic model is correct, then the singularity has always existed, and it is simply the beginning of the next cycle of expansion. In the first few moments after the Big Bang, the universe was incredibly hot and dense. As the universe expanded and cooled, particles began to form. The first particles to form were quarks and gluons. Quarks combined to form protons and neutrons, which are the building blocks of atoms. Over time, gravity caused the particles to clump together, forming stars and galaxies. The first stars formed about 100 million years after the Big Bang. The universe has continued to expand ever since the Big Bang. Today, it is a vast and ever-changing place. In recent years, scientists have made significant progress in their understanding of the origins of the universe. For example, they have discovered evidence for cosmic inflation, a period of rapid expansion that occurred in the very early universe. Scientists have also discovered dark matter and dark energy, two mysterious substances that make up most of the universe. While scientists still don't have all the answers about the origins of the universe, their research is helping them to better understand this amazing and complex place. The origins of the universe are one of the greatest mysteries in science. But scientists are making significant progress in their understanding of this topic. The theories about what was before the Big Bang and how the universe came into existence are fascinating and thought-provoking. And the latest research is helping us to better understand the early universe and the role that cosmic inflation, dark matter, and dark energy played in its evolution. If you enjoyed this video, please like and share it. And don't forget to subscribe to our channel for more videos about the universe and beyond. Thanks for watching.